I spent most of my career as a founder. I started a company called Hyper, where in 2014 we had the bright idea to build an AI travel agent. It is 2025, and I can tell you we were probably a little bit too early. My last company, Macro, was a tool that helped non-technical employees automate their processes. And in Macro, we had, I think, an exciting insight, which was that the first step in automating a process is to document it. Now, I'm no longer a founder, but these ideas, the idea that agents could be a colleague, that the enterprise could be something programmable, these are ideas that still inspire me and still motivate a lot of the work that I do as an investor. I'm now a partner at Upfront Ventures. We're a venture firm based in Los Angeles, where I focus primarily on AI, dev tools, and infrastructure. And on this slide, you can see some of the great companies that we've backed, like Daytona, Bland, Ryder, and a number of others. Today, I want to share with you 3 ideas. The first idea is that new AI capabilities lead to new ways of collaborating with AI. The second idea is really an application of the first, which is that new modes of collaboration with AI are starting to emerge, and they're emerging as a direct result of the arrival of reliable coding agents. And finally, I want to close with a comment which I think is pretty important, which is that the way that we build software with AI tends to be a bellwether for the way that AI takes shape in other parts of the org. So to get started, I want to talk about the last 3 years, where we've seen the arrival of various modes of AI collaboration. I remember in the summer of 2022, the first time that I used Copilot. And I used to tell people that Copilot was one of the best software products that I'd ever used. Copilot was magical. It's still magical. And the big unlock that gave us Copilot was a model called Codex. But lucky for us, Copilot wasn't the end of the story of AI and software development. We saw the arrival of what I call supervised agents, like Composer in Cursor. And Composer was amazing because it let us perform relatively complex tasks that required editing multiple files simultaneously. And here, we have to thank Claude Sonnet 3.5. In the last year, we've seen the arrival of what I call reliable asynchronous background agents, like Claude Code. How many of you have used Claude Code? My hunch is that you are somewhat as enthusiastic as I am about Claude Code. I love Claude Code. I sometimes describe Claude Code as the first agent that I actually trust. And the thing that's made Claude Code possible, of course, is the arrival of reasoning models that allow for extended chains of thought and planning for complex tasks. Well, I'm going to propose to you today that Claude Code itself is a new unlock. And specifically, Claude Code is enabling new modes of collaboration with AI. And the first mode of what I call collaboration with AI is task orchestration. I define task orchestrators as interfaces where tasks are defined and distributed to coding agents. In its very simplest form, an orchestrator feels a lot like a task management tool. This, in fact, is a screenshot of me using Linear. It used to be the case that in Linear, you could assign tasks to humans on your team, and today, crazy enough, we can assign tasks to agents. But there's also a new crop of startups that I've started to see over the last few months that are specifically focused on helping developers manage a fleet of agent workers. And to some extent, these new products actually don't really look like product management tools. In fact, the way that they describe themselves is they're ways to manage multiple sessions of Claude Code or equivalent agents. So what is the difference? Is an orchestrator just a task management tool? Today, I would say probably. They are very similar. Specifically, what they have in common is that they're both interfaces where work is defined, and you have the ability to send this work off to agents that you've recruited to your team. But what's unique about orchestrators? Two big things. And the first one's going to seem silly, but I mean it wholeheartedly. Orchestrators are really fun. I've never had the experience of writing software this way, but sometimes I will find myself struck by an interesting idea, and in between a task, or even if I have, if I'm cooking, I might go to an agent and give it. I might go to an orchestrator and give it an idea that I have for a new feature. And by the time that I'm done cooking, come back and see that there's a new feature for me to review. It's crazy, and it's also really cool. The other thing that is unique about orchestrators is that they're purpose-built for working with agents. And that reframes the product scope. Today, I don't think there's that much difference between an orchestrator and a conventional product management tool. But over the long run, I think that these two different types of products are going to diverge even more. So why use an orchestrator? Why not just use Claude Code CLI or another agent through their interface? Well, I think one principle that's really important in this era is the idea of agent neutrality. In Cursor or a lot of other AI products, users are given the flexibility to choose the model that's best for them. Well, I think that a similar idea is relevant when we choose what agents we want to use. It may be the case that when we use Claude Code, we're using Claude Code for front-end tasks, and we might want to use Codex for another type of work that we think Codex is better at. That could be a hypothetical, but I actually really do think that we will develop more opinionated views about how we use each of these agents. I'd also say that working with agents introduces new problems and new bottlenecks. How do we control agents? The way that we work with agents today can be compared somewhat unfavorably to the idea of bringing on a new employee and then telling them, yeah, here's the code base, go run wild. So I think over time, we'll start to look into how can we give our new agents employees more guidance, but also how, as their managers, can we control their behavior. Another problem, this is both a good thing and a bad thing, it's never been easier to produce more code, but that also, in creating a more volume of code, it also leads to more code to review. And I think there's a weird disparity between the experience of someone like me who, at this point in their career, all the code I write is for myself. Nobody else is reviewing my code. So if I ship crappy code, the only person that I have to be ashamed of or the only person that I'm accountable to is myself. Whereas if I work at a software org with a lot of other engineers, if I start shipping agent-produced code that's pretty bad, that's a pretty bad situation for me as an employee. And so this burden of how do we review AI-generated code, I think, is going to become an even bigger problem over time. And then finally, what are another bottleneck? I think this is actually perhaps the biggest bottleneck, is how do we actually communicate clearly to agents? There's a great quote from Sean Grove, who gave a talk a few months ago at the AI Engineer Conference, and he said, "Whoever communicates best becomes the most valuable programmer." Well, I agree. The long-term bottleneck when it comes to working with coding agents is probably us and our sometimes disappointing ability to communicate what we want. Now, I think that represents the opportunity for some of these tools, because what they can do is they can help to offset our deficiencies, as all good software does. So, can we have an orchestrator that takes a look at our instructions and indicates to us where our instructions have gone wrong? I like to say that does it make sense is the new does it compile. Can it identify ambiguous language, kind of function as like a natural language linter? Can it split up large tasks into smaller, isolated chunks that are more easily testable? And can it lower the cognitive effort that it takes in communicating really complex ideas? I do want to note one thing. Vagueness is sometimes a virtue. Sometimes I don't know how I want a feature to be implemented. And so it's actually kind of fun to see what the agent sees as their best judgment. So what's next for orchestrators? Well, I've already talked a bit about this, but I think code review is one area of potential expansion for orchestrators. And I think the speculative idea here is that the process of reviewing code that has been written for you as a single stakeholder in the inner loop is actually different from code review in the outer loop, where it's more about the collaboration with the rest of your engineering team. I'd also say that as a principle, context drives clarity. One of my favorite things about, I don't use Lovable, but I have played around with Lovable, and one of the things that I really admire about Lovable is the idea of the live app preview, that you get instant feedback based off of your last instruction. So you instruct Lovable, and then you can see how Lovable handled your request. And you're able to communicate really clearly about what it did well or what it didn't do well because you see it right there in front of you. I'd also say, and I see this as a conceptual, this is a concept that I haven't seen anyone else work on, and I invite people to pursue this idea because I think it's quite promising, which is the idea of using documentation as a substrate for editing code. So I call this a natural language diff. You might ask an agent, how does a certain piece of functionality currently work? And then in looking at that explanation, you can annotate that explanation and suggest you can suggest alterations for how you would like that feature or how we'd like that feature to be architected. And of course, the North Star here is you need to become the principal tool that developers use to work effectively with agents. And again, I think a really big part of that is just helping developers communicate more clearly. The next mode of cooperation with AI that I want to talk about is what I call autonomous loops. An autonomous loop analyzes signals from what I'm calling sensors, but you might think of as systems. It specs out new tasks, and it ships code that advances business objectives. So what does an autonomous loop look like? Well, I see three phases. The first phase is what I'd call observation. How is the app performing? The next phase is specification. What should we be building based upon what we've seen? And finally, development. And here is that critical unlock, that development piece. We are so close to having Claude Code power pretty much everything within that column. And if you take a closer view, you see that the observation phase of this autonomous loop is actually not just one loop, but it's actually several. And each of these rows, whether it's product analytics or observability or qualitative feedback or business intelligence, each of these can produce signals which leads to an autonomous loop in themselves. And for some sensors, that autonomous loop is already running. I really love what the Sentry team has done with their Seer product. So Sentry is, they do error monitoring, and it used to be the case with Sentry that when a new error was detected, it was left for the developer to take a look at the error and then go remediate it on their own. And now we can actually have the agent remediate that error themselves. So you have that full loop, which is really cool. So what is the future of autonomous loops in the product org? Well, I think it comes down to new sensors. Can we analyze session replay at scale? Can we analyze agent interactions, customer feedback? What about experiments, running A/B tests, and then based upon the experiment that performs better, actually going ahead and shipping that feature? One final idea for you. I talked about this before, but the idea that what we see in software development with AI tends to predict what we see in other domains. I think the best example, we saw this with GitHub Copilot. GitHub Copilot was the first Copilot, and then developers saw how powerful AI was and how powerful an in-app assistant could be, and they went ahead and brought that experience to other domains. Well, I think this actually gets at a really interesting dynamic in AI, which is that the models are at the vanguard when it comes, or excuse me, code is at the vanguard when it comes to new model capabilities. And there are a lot of reasons for this. Like one of them is obviously abundance of training data. Another is that code is a verifiable domain of work. But the cool thing about code being such a frontier capability is that it leads, as we've talked about, to frontier interaction patterns. And so we've seen Copilot in developer tools migrate or diffuse into other domains. Well, I think that the future interaction patterns that we've talked about today are also going to diffuse into other categories. And so if I think about, like, what does the future of managing agents look like? Well, I think one potential place to look is the task orchestrators that we see changing the way that we do product management. And if I think about what does the future of the autonomous firm look like, well, I'd say take a look at what the autonomous product org looks like and all of the various loops that we're going to start stitching together. That's it. Thank you so much.